So in this final video on coordinate geometry, which I'm sure many of you will be glad to hear, we'll be going through the practical questions involving circles in coordinate geometry. Now, these questions are very, very popular when it comes to exam style questions or the latter parts of exercise in textbooks, simply because it combines a wide range of algebra skills with coordinate geometry skills mixed in with the equation of a circle. So not only does it test your ability to work with quadratics and simultaneous equations and factorizing, using completing the square, etc. So that's why it's quite a big favourite when it comes to exam questions, because it ticks a lot of boxes and gets you to test a wide range of your algebraic skills. Now in this video I'm not going to go through actual questions, but I'm going to go through a list of key and common questions that usually get asked at this level and how to go about solving each of those problems. So what I've done is I'm going to go through 9 of the most commonly asked questions related to circles and coordinate geometry. So to start us off, what we're going to do is we're going to show that a point lies on a circle. So to do this, what we need to do is follow these following steps. So to show that a coordinate lies on a circle, substitute the x and y ordinate into the equation of a circle regardless of what form it's in, and if those values along with your centre of coordinates add up to r squared, then the point does lie on the circle, and if it doesn't, then it doesn't. So what we mean by this is you will end up with the equation of a circle either in the format of x minus a squared plus y minus b squared equals r squared, or you might end up with something along the lines of, let's go for different letters, so let's go for cx plus y squared plus dy plus e equals r squared. Now, if you end up with an equation, a coordinate with the values of x, y, so this is a coordinate that we are checking. So what this method is actually telling you to do is substitute x and y into either of these two equations, or whichever how it's given to you, and if that adds up to r squared, then it does, and if it doesn't, then the point lies outside the circle. And that's basically it. So, and obviously when it comes to these types of questions, it's worth adding as a final statement is, as let's say this equals r squared, then the point lies on the circle. So again, just to summarise, whenever it asks you work out whether a point lies on a circle or show that it lies on a circle, just substitute the x and y ordinates of that coordinate into the equation of a circle, replacing your x and y values. If it equals r squared, then you're in business. If not, then the point does not. So moving on to our next example. Now again, there's two variations on this one. So given the equation of a circle, find the x and or y intercepts. So to find the x-intercepts or the y-intercepts, it kind of works in the exact same way of when you're working out the roots of or sketching a quadratic equation. So to find the x-intercepts, you've got to make y equal to 0 into the equation. Now for this, what we need to do is substitute x naught as the coordinate, where x is obviously what you don't know because you're trying to find what the x ordinates actually are, and you know what the y ordinates is because that's going to be 0. So anything that is going to intercept the x axis, as you can see, the y ordinate of each of those little x's is going to be, the y ordinate is going to be 0. And that's one of the reasons why we substitute this coordinate in. So once you substitute that, replacing x and y in your equation of a circle, and so there you go, and then what you'll end up with is just one single letter. So for this, the y's will disappear. So once you've done that, expand the brackets, simplify the expression and make it equal to 0, and it'll slowly start to look like a quadratic equation. Now once you've done that, what you then want to do is solve that quadratic equation, and that will give you the x ordinates. Now obviously the respective y ordinates for that are going to be 0, so it's good practice for you to write the answers as a coordinate as it is related to a graph. I don't want something there. There you go. Oh, keep doing that. Right, so, and now if the quadratic is not solvable, then that would show that the circle does not cross the x-axis. So if no solution, that's just worth writing that down. So if no solutions to the quadratic, then the circle does not cross the x-axis. And again, it kind of links with discriminants in that case, because you'll end up with no roots, which means that there's no solutions for it. Now, in a similar aspect, to find out where it crosses the y-axis, all we need to do there is we do the exact same. However, this time what we do is we substitute x and y for 0, y. And again, we substitute those numbers into the equation of a circle, which then we'll end up with an equation that just involves y's. We turn it into a quadratic equation, make it equal to 0, go on and solve it, and the answers to that would give our respective y ordinates of where it crosses the y-axis. Now again, we'll move on to these types of questions before. If you find that there's only one solution, then that will therefore show that the y-axis or the x-axis is a tangent to the circle. So if no solutions, then the circle does not cross the y-axis. And again, sometimes you might get asked to prove that it does, sometimes you might get asked to prove that it doesn't. So it's important that you're able to understand what your answers are telling you. If you end up with two answers, it means it crosses it twice. If it's got one answer, it shows it's a tangent. And if there's no solutions, then it doesn't cross at all. So moving on to our third point, which is prove that or find to see if a point lies inside or outside a circle. So for this, there are a couple of steps that you need to adhere by. So the first thing you need to do is find r. Now that might be just by looking at the equation. You might have to do a bit of rearranging depending on the question that you've got. But the first step is what you want to do is write down your r value. So without any working out or with working out, write down what that answer is and you write that down there. Now the second thing you then need to do is to find the distance between the point. Now on this diagram, if I just show where the radius is. Now if the coordinate, well, let's say there, we'll just call this coordinate P. Now if the coordinate lies inside, and this is the centre C, so if I work out the distance between P and C, which we will call D, now if point P lies inside the circle, then that distance, using the centre coordinate as a common sort of coordinate that's used in both formulas, that D should be smaller than R, or in other words, R should be bigger than D. And if that is the case, then point P will lie inside the circle. Now if I just get a different colour, let's go for orange. So for example, let's say P was outside the circle and I work out the distance of CP. Now as you can see here, if the point lies outside the circle, then D is going to be bigger than R, or that R is going to be smaller than D, depending on how you decide to write it. So, and that's all about interpretation. So the key thing in terms of your conclusion is this. Now when you are asked to prove that a point lies inside the circle or outside the circle, it's always good practice for you to quote either one of those two lines in that little orange bubble. So for example, or by stating this, the inequality part of that statement. And it's really important that you kind of do the finishing touches to your answer rather than just assuming that whoever's reading or marking your work knows exactly what you're doing. Yes, it's very mundane, and yes, you might seem it's quite pointless, but it's certainly something that is worth doing to maximize your marks. So moving on to step 4. So step 4, what we're doing here is we are finding the coordinates where the circle intersects with a line. Now the key thing that you need to, the key word in this is that, which is mentioned in a previous video, is whenever you see the word intersect, odds are it's going to relate to simultaneous equations. So whenever you see the word intersect, always think simultaneous equations. Now to find the coordinates of where it intersects, all we need to do here, so for example, what I've got is the equation of this circle is going to be in the form of, let's say, x minus a squared plus y minus b squared equals r squared. And this is going to be y equals mx plus c, or it could be something completely different. It could be in the form of a y plus bx plus c equals 0, depending on how the equation of a line is given to you, depending on how difficult the question is going to be. So the first thing you want to do is make y the subject. So here, try and get it as y equals, and I would say not it's quite rare for you to make X the subject. More often it is tend to be Y the subject, but regardless, it's entirely up to you, but try and go for simple ones that don't involve fractions. So once you've made Y the subject, what we then want to do is substitute it into the equation of the circle. So we're going to substitute it into this. So what if this was the case, now I don't want to go too algebraic because it may confuse you, but let's say that we're going to substitute this. Let's say we had Y equals 2x plus 4. Let's actually write that in a different colour so we're not to get confused. So come on, let's write it in blue. So let's say, for example, we had Y equals 3x minus 1. So what I'm going to do is in the equation of a circle, and again, it could be written in this format, it could be written with the brackets expanded, so like x squared plus bx, not bx, in terms of coefficients of x plus y squared plus coefficients of b equals whatever r squared is going to be. Now in this case, all we're going to do is we're going to substitute wherever we see a y with 3x minus 1. And so what I'll end up with is something that looks like that. Now obviously your A and B are going to be the centre, so although we've got like almost like the alphabet, that's just going to be numbers. So A and B will be given to you. So here, as you can see, if A and B were numbers, all we're left with, as well as R, forgot the radius, then all we'll end up with is an equation that just involves x's. So what I'd need to do is expand the brackets, simplify it, make it equal to 0, solve the quadratic equation either by using the formula or by factorising, and then I'd find the x ordinates. Now once I found those x ordinates, what I then want to do is substitute it back into the equation of a line, only because that's going to be the easier out of the two equations to find the respective y values. And again, as is related to a graph, always write down your answers as coordinates. Now going through this again, it's linked with discriminants, so a question might ask you to not only find the intersection points between a line and a circle, it may ask you to show that the line is a tangent. You might go for the complete opposite, in which show that a line does not intercept with a circle. So at this stage here, when we are solving the quadratic equation, then what you need to do, so if the quadratic has no solutions, then the line does not intercept the circle. So it's worth just making sure, and again, heavily links with discriminants, which is why these types of questions related to circles is so popular, by the fact that they combine a lot of algebra, a lot of coordinate geometry, and a lot of basic theory. So moving on to number 5. So again, find the equation of a circle given two coordinates that are opposite ends of the diameter. So this is where coordinate geometry comes into play. So it's worth, what I've done here is the 3 steps that we need to do to answer this particular question. And what I'll do is I'll show you on the diagram where this all makes sense. Now, if we've got two coordinates that are opposite ends that form the diameter of a circle, so let's just let's go for blue. So for example, let's say we've got 2 points here and we've got C in the middle here. Now, to find the equation, what we need to know, let's call this point M and N. So to find the equation of a circle, I need 2 things. I need to work out what the centre is, and I need to know what the radius is. They're the 2 key bits of information I need to work out the equation of a circle. Now the centre is going to be the midpoint between, so the midpoint of M and N, and the radius is going to be the distance between M and N divided by 2, because that will give me the diameter, and dividing it by 2 will give me the radius. And once I've got those 2 bits of information, all I then need to do is substitute that into the equation of a circle, which looks like so, and there we are. And this will give me my A, B value, and this will give me my R value. And so following those 3 steps should make it a little bit clearer what we need to do. And again, once you've got your formula, a question might ask you to write the equation of a circle in a particular way, or you could either leave it in its unexpanded form. So moving on to the next one, So number 6. So here it's a case of, now we've mentioned this previously, it says to number, in this question asked to find the number of intersection points a line or axis has with a circle. So if again, whenever you're looking at word in terms of finding how many times or how many roots there are, try and think of the word, or try and think of the topic that is discriminants. So the key thing to note here, and there's a few diagrams here, so in this particular case, we've got 2 intersection points. So 2 points. Here we've got 1 point. And here we've got no intersection. And again, with regards to this, we just need to follow these 4 steps. So the first thing you need to do is make y or x the subject in the equation of a line. And again, sometimes this might be already done for you. Substitute this into the equation of a circle. Then expand the brackets, simplify it, make it equal to 0. And then using ax squared, which should be in the form of a quadratic, so that should be a quadratic. And then once you've got it in its quadratic form, we're going to use the discriminant to find out what it is. Now, in terms of your conclusion, this is what you need to include. So it's not just good enough for you to say what the discriminant value is or to guess. You need to quote one of these 3 things to show or prove what it is. So once you found the discriminant value, let's say the discriminant value was 6, then you would say as b squared minus 4ac is greater than 0, the line intercepts the circle at 2 points. If let's say it was, I don't know, minus 13, then we'd say as b squared minus 4ac is less than 0, the line and the circle do not intersect. And likewise, if it was equal to 0, the line would therefore be a tangent. So again, it's a key thing and key words that you need to look out for, because with regards to these questions, they do like to chuck in a lot of topics, and that's what A-level maths is about. It's to make questions a little bit more difficult. They just merge topics together. So moving on to number 7, we've got here is find the equation of a normal at a given point P. Now for this, now we've not looked at differentiation just yet, which again, normals and tangents will come up quite prominently in that. So in this particular diagram, what we've got here, this blue line is our tangent because it only touches the circle at 1 point, and this red line that we've got, let's get a red colour pen, there we go, and this red line rather, is our normal. Now we've been asked, and it's at point P, so let's just get a different colour pen, and this is our point P. So in this particular question, you'd be given the equation of a circle, you'd be given the coordinates of P, so let's just call this xy, and we need to find the equation of that red line. Now to find the equation of a red line, what you need 2 bits of information. So to find the equation of a line, you need the gradient and you need a coordinate. Now, to find the gradient of this, and then once we've found those 2 bits of information, so this is going to be our m value, this is going to be our x1, y1 value, and then what we then do is substitute that into y minus y1 equals mx minus x1. So, to find the gradient of this red line, that's going to be let's get a difficult pen. Right, so to find the gradient of the normal, that's the gradient of the coordinate CP. And again, if you're not sure how to do that, we've got a video on that, but the formula to do that is that one there. And then to find the coordinate, this is where you need to use point P. And again, try not to get too confused with using C. It's point P that we're looking for because that is a line. Well, actually, it doesn't really matter. We can use point P or the center. I would probably opt for the point P, only because I know what I'm going to go through next with number 8, but try and use point P. And then once you've substituted those values, we've got it into this form, and then you can either write it using integers, so if you end up with fractions, or you can write it in the form of y equals mx plus c, or whichever you prefer. And again, it's worth making a note of those 3 steps, which will help you answer those types of questions. So the next thing we move on to, and as we've kind of previously mentioned there, is find the equation of the tangent. So as you can see, with regards to this, it's near impossible for you to work out the gradient of the tangent without first of all working out the gradient of the normal. Because as you can see, to work out the gradient, we need 2 coordinates. And on the tangent, we only know that there's one point that passes through that tangent, and that's point P. So to do this, what we need to do first is to make a note of the coordinate of the center. So again, you might have to do this, sometimes you may not need to. And then the second step is find the gradient of point CP, and that will give us the gradient of the normal. And then what we then need to do is do the negative reciprocal of the gradient of the normal to give us the gradient of the tangent. And then, just like we did before, is using the coordinate of P, substitute it and the gradient of the tangent. We substitute that into y minus y1 equals mx minus x1, and then we simplify that equation as per requested. Then for the last and final part of this particular video that we're going to go through is showing that a triangle inside a circle is right angled. Now this mixes in with a bit of circle theorems. So what I've done here is just drawn a diagram where we've got our three coordinates D, E, F and our centre mark C. Now for this, what we need to do is, and if I just emphasise that point C, so for this, so it must state that EDF, so the first thing you want to do is make sure that EDF lie on the line. Now it might be stating the obvious, and in some cases in the question it will say that these three coordinates lie on a line, show that the vertices make a triangle, make a right angle triangle I should say rather. So first thing you want to do is show that EF is the diameter of the circle. How can we do that? Well, you use the distance formula. So the distance of EF, we use the formula of square root of x2 minus x1 squared plus y2 minus y1 squared, and that's all square rooted. And we show that that's equal to 2 lots of the radius. Now if that is the case, then EF is the diameter of the circle. And once you've got that, what we then need to do is quote the circle theorem, which states that the angle at the circumference in a semicircle is 90 degrees. And so if that is the case, then your triangle will be a right angle triangle. So it's worth making a note of this. So just to summarize the steps in this particular question is work out the diameter of the, well, work out the distance between the two furthest points. So you might have to do a bit of jigging on this one. So you'd work out the distance of DE, EF and DF. Now hopefully if it is a right angle triangle, then one of those two distances will be the diameter of the circle. And again, you can work out the diameter of the circle by looking at the equation of the circle times the radius by 2. And if they are the same, then that triangle is definitely going to be a right angle because of the circle theorem that's mentioned on the screen. So as I said, I've not gone through any particular questions. I've just gone through the steps because the video would probably take an hour and a half. But like I said, if there are any questions that you're not too sure about, please do drop me an email at 162maths@gmail.com. Or if you'd like a